So let's basically redraw this a little bit to demonstrate what we're gonna do next. So right now, inside of every stack object, we will have essentially this memory block, right? Which is a pointer to a block of integers. However many integers we have allocated, it's going to point to that memory. That memory, of course, is stored on the heap or free store in C++, because that's where the dynamic memory is something that is a special a memory segment where the things can be allocated and deallocated dynamically. Then, of course, we have top of stack, right? Top of stack, which is just an integer, which essentially, I will kind of circle it like that, which basically just remembers where the next available element is. Okay. And now we added the capacity. Capacity, right? It's just another integer, which basically remembers how many elements are there. So it's essentially it remembers the size or something like that. But let me redraw this one more time. This time, I will draw this with this extreme case where the initial size was just one integer, right? So there's one integer to which this block, memory block, is pointing to. The top of stack, of course, is 0, right? It's 0, so it's pointing to this initial element in that memory block. And the capacity will be 1, right? Because remember, the default capacity is 1, right? The default capacity was set to 1 for the purposes of debugging all of this behavior, right? And so the default size is 1, we pass block size as 1, and capacity is populated by this constructor with calling allocate memory, populated with 1, right? So capacity essentially points to the next, if I think about my capacity as an index, essentially it points to the element, an imaginary element which doesn't yet exist, right? In case if the stack dynamic memory needs to grow and become bigger, I can essentially compare top of stack with the capacity, and after the first push, right? If I say push 11, right? 11 is going to be stored over here, but the top of the stack will be incremented and will become 1, and so it will be pointing right here to this non-existing element in memory. Therefore, I am thinking that what I could do is when I do a push, before I do the push, I need to say if, right? If the capacity equals the top of stack, right? If all of a sudden, if I compare capacity to the top of stack, under that condition, I need to allocate more memory, right? I need to say, just type this, I need to say allocate more memory. Okay, unfortunately, I need to grow this dynamic area. So how could I do this? Allocate more memory. How can I implement something like that? What I'm thinking is this. So the challenge is, under this circumstances and everything, we need to allocate more memory. What we need to do is step number one. What we need to do is perhaps we can allocate a bigger block of memory somewhere else. Okay? So allocate, so step number 1, allocate a bigger block of integers. Step number 2, we can copy the existing values over to this brand new block with more capacity, right? So copy existing data elements over to a new memory block, right? And number three, we can say once we're done with this, we can free this memory, right? Free old memory block, because we don't want memory leaks, right? So essentially we want to deallocate previously allocated memory block. And finally, I'll just write it at the top, number 4, basically point stack to the new memory, which is memory here, right? Which is simply basically just what we need to do is to point this memory block to this new place. Okay, so that's the steps. I need to think about these 4 steps. If I can accomplish something like that, my stack obviously will be bigger capacity, and now I can keep pushing elements. Okay, so let's do this. Of course, I am thinking that this specific action should allocate more memory. Should be another private operation which should not be externally available. I will only do this internally inside my class. And what I'm going to do is that I'm going to basically copy and paste. This is going to be something similar, but this time I will say reallocate memory, right? Reallocate memory, and the block size will, as a parameter, will indicate the new block size. Or maybe I can, whatever, let's just keep the same function signature for both initial allocate and reallocate. Let's just go and try implementing this function. So again, so what we can do here, if we have this implemented, reallocate memory, what we can do over here, we can just simply say reallocate memory, and we can say whatever the current capacity is, right? We can multiply our capacity by 2 or 3 or something like that, right? So our strategy may be that we can double the capacity, right? So we reallocate memory and we double the capacity every time we run out of dynamic memory space, right? We can just reallocate the capacity. Okay, if that's the plan, so that's supposed to be saying value. Okay. So we need to implement this function, new member function, which we now considering to be a useful addition to what we do. So I'm just as before, it becomes routine. Control-C, copy it over to our implementation, and perhaps logically I can keep it next to allocate memory, right? So I can basically add this here and say in stack, right, the same preparation, in stack reallocate memory, get rid of the semicolon, and then I am now ready to do it, right? So let me save everything and actually write the implementation for this new thing.